This is Geology 100 Natural Disasters. My name is Scott Nowicki, and this is Volcanoes Part 2. Stratovolcanoes are produced from a combination of explosive or these pyroclastic eruptions and fluid lava eruptions that occur repeatedly again and again over time. Typically, they're felsic in composition. Classically, these are the rhyolitic volcanoes, but they can be intermediate in composition as well. The key is they are not mafic. The mafic volcanoes have very fluid lavas that cannot produce these very high and steep volcanoes. Now, Mount St Helens and the other Cascade Mountains are directly related to subduction of the Juan de Fuca plate that is occurring just offshore of Oregon, Washington, and British Columbia. So these stratovolcanoes are very typical of this tectonic setting, where one plate is being subducted and being melted and then rises as these volcanoes through the crustal material. They are these alternating layers of lava flows and pyroclastic layers. There are big eruptive events with lots of ash flows and pyroclastic flows, and then as the gas runs out of that eruption, the next eruption is a relatively fluid lava. So again and again over time at Mount St. Helens, there is this repeat of pyroclastic and these stickier lava flows. So Mount St. Helens is one of these stratovolcanoes. In 1980, it erupted and blasted off the top third of the mountain. But the reality is this is standard for what Mount St. Helens has been doing over the past 30,000 years. A big, violent, gas-rich eruption is followed by these slower flowing, stickier lavas that build up more and more mass within the volcano. Lava domes, such as this one at Mount Lassen, or at the lava dome in Mount St. Helens, are eruptions that occur on the stratovolcanoes. If there are large eruptions with big magma chambers, often these calderas can form. Here is a caldera at Kilimanjaro that shows the magma chamber at depth had lots of magma within it, but then as it erupted out of the top, that void space that occurred within that magma chamber allowed the surface to collapse in on itself. Fairly often on these stratovolcanoes or on these felsic compositions, there are these calderas that form. Collapse pits that occur because that inner magma chamber collapses in on itself. A good place to see these stratovolcanoes are all along the Cascade Range. From Mount Lassen in California to Mount Baker and higher into Canada, there is this line of felsic volcanoes, most of them stratovolcanoes, that are directly related to that Juan de Fuca plate being subducted offshore. When we look at stratovolcanoes, these tend to have the higher hazard features and characteristics. There can be large-scale eruption clouds, there can be pyroclastic flows. If there's a lava dome that forms, the lava dome can collapse and cause a pyroclastic flow, just like we saw it at Mount Unzen. There are debris avalanches or landslides. There are lahars, which are effectively mud flows that are caused by the melting of snow and ice up higher on the volcano. During this violent eruptive phase, bombs can be thrown out, and bombs are any lava that is actually flung through the air. And all of these characteristics can produce, of course, hazardous situations depending on where you are in proximity to this volcano. Each of these hazards has a specific area that it could potentially cover. And there's more information about these hazards on the USGS website. A recent eruption that brought the world's attention to these volcanic eruptions was the Eyjafjallajökull eruption in Iceland in 2010. This was a volcano that erupted and produced a large amount of ash that went up into the atmosphere. That ash is extremely hazardous just when it's sitting up in the air. Here's another shot of that eruptive phase. That ash and gases are rising up and then proceeding to get blown by the wind further and further away from the volcano itself. The problem with this, of course, is that ash is actually composed of very small particles of rock. So any planes that might potentially fly through this plume of ash could pull in that debris into the engines, and it causes all sorts of trouble. This ash cloud wound up closing a number of airports in Europe due to the risk of flying through the ash. The planes can actually fly above the ash cloud because it was occurring at about 20,000 to 35,000 feet, but in order to actually get up to that height, of course, the planes would have to fly up through the ash cloud For that reason, there were large-scale closures and a disruption of the global transportation system just from this one volcano. So even though these look like they're relatively small scale features when we look at the overall globe, even a small scale volcanic eruption can produce some pretty widespread effects. It took a long time for this eruption to occur, but once the ash made its way up into the upper atmosphere, it started to blow out over wide areas. And this is really the hazard that we are most concerned with these ash-rich eruptions. Now, of course, the ash overall isn't that big of a volume. It's probably cubic kilometers worth of ash. But spread out very thinly, it can cause huge amounts of damage in a wide area.